Here we go. We have a question. Sort a k-sorted doubly linked list. So you have given a doubly linked list. Each node is at most k indexes away from its target position or correct position. The problem is to sort the given doubly linked list. The distance can be assumed in either of the directions, left or right. So we have this, and in this is the first input, and this is the expected output. So this one node is k distance away from its original. This is in its correct position. This 3 is k distance away. Then this 4 is k distance away. This 5 is k 1 distance away. Then this 6 is also 1 distance away. In this case, k is 1, k is 2, sorry. Then in this 3, 1, 2, 3 is k distance, means 3 distance away. Then this 4 is also 3 distance away. This 4 is also 3 distance away. So I hope you got it. So let's try to build the approach. I have taken this example. In this example, this 3 has to be here. So first, we know in this case k is 3. So this 3 is k distance away. So we first need to find the k values. So and after that we need to find the minimum of those. So priority queue will help here. So let's first add 5, then 6, then 7, then this 3. Now this this element is k distance away from the original. So what we do? We first need to pop out the element. So let's pop out the element, and we have these 3. This 3 is linked already. So we are not considering these links. We create the new links. So initially it is linked, but what will I do is initially our head and current is null. So this is the first value, this 3 is the first value. So while we pop out, we check, is our head and current null? Yes. So we create a new node of value 3, or either we can create a new node, or we can directly get this 3 value, this 3 node, and initialize the head and current to this node. So let's find the new value. Next value is 4. So let's add 4 here. Now k is 3 and this value is k distance away. So let's first pop out this value. So we have a value here. Then current, this is the pop out value. What will we do is this current next is pointing to pop, and pop dot previous pointing to current. Current move to its next. Then next value is 4. So next value is 4. So we pop out the 4, and this is the pop out value. Current dot next is pop, pop dot previous is current. Current moves to next value. So we have some value here. Let's first pop out 5. 5 is the smaller value. This is the pop. This is so we create a link pop. Then next value is this. So I hope you got it. So next we just need to return this head. So this head is already linked to uh, all the nodes, and it's in ascending order. So we just need to return our head. So let's try to implement it. So we have head, and we need to also return the head of the sorted linked list. So first we have a priority queue. Priority queue. Next we have this. We iterate. So for iteration, I am using current current head. Current head initially pointing to current, while while condition current head not equal to null. Then we need some values. First is the answer is null, and current answer, it is also 1 initially. Then we first need to add the current value into the priority queue. So priority queue dot add. So let's add the node itself. So I am directly adding the node, and we have comparator. In the comparator we need sorted values. So o1 dot, I think it is data. Yes, it's data. So o1 dot data minus o2 dot data. So using this anonymous comparator, we can directly compare, and I am directly adding the node itself. So let's add current head, and as you know, current head will move to next value. Current head is equal to current head dot next. So we need to check something. Is a priority queue size equal to k plus 1? If priority queue size is equal to k plus 1, means there is a node and it is k distance away from its original value. So then uh, we need to pop out a node. So this is a node, and this is called pop out. So we need to remove a value from a priority queue. So after removing this value, then we need to check, is our answer null? If our answer is null, then this node will become the head, and current answer is also pointing to this pop value. If answer is not null, answer is already pointing to the head value, then current answer dot next will point to this pop, and this pop dot previous will point to current dot answer. Then current dot next, current answer will go to next node. Current answer dot next. And I think I missed a link here, that is this 3 is already connected, is this 3 previous is already connected to 7. So this 3, here we have 6, and here we have 7. This current, and current is pointing to here. So what I missed is, initially this 3 is added in the priority queue, and while removing we have these 3. This 3, its previous and its next is already linked to some node. So its previous is linked to this node. So either, in this case it is pointing to last node, either it can point to this, it can point to any node. So we need to add its previous to null and its next to null, because its next is I think its next is pointing to 3. Yes. So we need to disconnect the links here. So let's disconnect the links. So head, not head, head dot answer dot previous is pointing to null, and current answer dot next is pointing to null itself. So let's return the answer, and let's try to run this code. We have a error, it is saying node. So node is not there, it is called DLL node, doubly linked list node. So let's give it a run. And we missed something. Yes, in this we added some values, but some values is already there in priority queue, because k values is there in priority queue. Whenever its size is greater than k plus 1, we are then removing a node, a single node, but some values are already there in the priority queue, so we need to add that condition here. If priority queue size not equal to 0, or let's write in this way, or what we can do is, I there's another way also. We can write priority queue dot is empty, and priority queue dot is empty, and before that just add a note symbol, and we need to pop out. So let's copy this line. So after this we have this condition, so let's copy this condition itself. If answer null, this will become new answer. If answer is not null, after current pointing to last node, after the last node we need to add this new node, and we need to establish previous connection. Current node will point to the last node, will point to the just added node. So let's give it a run now, and it is working. Let's submit this, and in between let's talk about time and space complexity. In this we are uh, in this we are traversing every node, and in this we are traversing k nodes. So it's time complexity is order of k according to this while loop, but we have also a priority queue. Whenever we add a value in the priority queue, either we are adding or we are removing, it will take uh, log n, but in this the elements in the priority queue is not n. N is the total number of elements, but in the priority queue we are adding k elements. So the priority queue time is log of k, log of k, and here we have a while loop iterating all values. So its time complexity is n log k, and space complexity is order of k, because in the priority queue we are adding only k elements. And this code is provided in the description box. We have successfully solved this question. If you have any doubt related to this question, either with the either with the while loop or the priority queue or the overall time and space complexity, you can comment down your issues in the comment section. And thank you all for watching.